In single-phase electrical systems, the question of how many circuits can share a neutral for lighting and receptacle applications is governed by the National Electrical Code, or NEC. The NEC provides specific guidelines to ensure electrical safety and proper circuit operation. Article 210.19a addresses this topic directly. It is important to understand the conditions under which sharing a neutral conductor is permitted and the limitations that apply. Firstly, to address the number of circuits, a maximum of 10 circuits can share a neutral conductor in specific single-phase applications involving lighting and receptacles. This allowance is subject to specific conditions outlined in the NEC. Secondly, the main condition for sharing the neutral is the use of a multi-wire branch circuit. A multi-wire branch circuit consists of two or more ungrounded conductors having a voltage between them, and a grounded conductor, with the grounded conductor equally loaded by the ungrounded conductors. In simpler terms, a multi-wire branch circuit is created by tapping the hot legs of a 240 volts supply, or a similar voltage, and sharing a single neutral wire. Thirdly, each ungrounded conductor must be protected by an individual circuit breaker. This means that each hot wire feeding the lighting or receptacle circuit has its own dedicated breaker in the panel. This is essential for overcurrent protection and preventing overloading of the neutral conductor. Fourthly, a key requirement is that the multi-wire branch circuit must originate from the same panel board or distribution equipment. This ensures that all the circuits sharing the neutral are supplied from the same source, simplifying the wiring and reducing the risk of voltage imbalances. Fifthly, the shared neutral conductor must be of sufficient size to carry the maximum unbalanced load. The unbalanced load is the maximum net current normally carried by the neutral conductor, which occurs when the loads on the individual hot wires are not equal. The NEC provides guidelines for calculating this unbalanced load and determining the appropriate neutral conductor size. Sixthly, it is crucial that the neutral conductor be continuous throughout the entire length of the multi-wire branch circuit. This means that the neutral wire should not be interrupted or broken at any point. Continuity of the neutral is essential for maintaining a low impedance return path for fault currents and ensuring proper operation of ground fault circuit interrupters, or GFCIs. Seventhly, all circuit breakers protecting the ungrounded conductors of the multi-wire branch circuit must be equipped with a common trip mechanism or be arranged so that if one breaker trips, all the breakers in the circuit trip simultaneously. This is often achieved through the use of a 2-pole or 3-pole breaker that connects all the hot wires together. This requirement helps prevent unbalanced voltages and potential hazards if one of the hot wires becomes disconnected. Eighthly, it is important to note that specific types of circuits and equipment are not permitted to share a neutral conductor. For example, circuits supplying sensitive electronic equipment or equipment that is susceptible to voltage fluctuations may require dedicated neutral conductors. Similarly, circuits supplying certain types of industrial equipment may have specific requirements that preclude the sharing of a neutral. Ninthly, the NEC contains specific tables and calculations that can be used to determine the appropriate size of the neutral conductor in a multi-wire branch circuit. These calculations take into account the anticipated load on each hot wire and the type of equipment being supplied. Using these tables and calculations is essential for ensuring that the neutral conductor is adequately sized to handle the maximum unbalanced load. Tenthly, in addition to the NEC requirements, local electrical codes and regulations may impose additional restrictions or requirements on the sharing of neutral conductors. It is important to consult with the local electrical inspector or authority having jurisdiction, or OJ, to ensure compliance with all applicable codes and regulations. The NEC specifies that a multi-wire branch circuit can have up to 10 circuits sharing a neutral. However, it's crucial to adhere to all the stipulations mentioned earlier, including proper breaker configurations, continuous neutral conductors, and load calculations. These requirements are put in place to mitigate potential hazards and ensure that the electrical system operates safely and effectively. It is also important to understand that while the NEC permits the sharing of a neutral in certain situations, there may be instances where it is preferable to use dedicated neutral conductors for each circuit. For example, In commercial or industrial settings where there are a large number of electronic devices or sensitive equipment, using dedicated neutrals can help reduce the risk of noise and interference on the electrical system. Similarly, in residential settings where there are concerns about voltage fluctuations or harmonic distortion, using dedicated neutrals may be a better option. The decision of whether to share a neutral or use dedicated neutral should be based on a careful evaluation of the specific application and the potential risks and benefits of each approach. Consulting with a qualified electrical contractor or engineer can help ensure that the electrical system is designed and installed in accordance with the NEC and all applicable codes and regulations. Furthermore, it is crucial to maintain accurate documentation of all electrical work, including the configuration of multi-wire branch circuits and the size and type of conductors used. This documentation can be helpful for troubleshooting problems in the future and for ensuring that the electrical system remains in compliance with the NEC over time. In addition to the technical aspects of sharing neutral conductors, it is also important to consider the safety implications. Improperly installed or maintained multi-wire branch circuits can pose a significant risk of electrical shock or fire. It is essential to follow all safety precautions when working on electrical systems, including de-energizing circuits before working on them, using appropriate personal protective equipment, or PPE, and following proper wiring techniques. The NEC provides detailed guidance on safe electrical work practices, and it is important to be familiar with these practices before undertaking any electrical work. Moreover, it is crucial to have a thorough understanding of the NEC and all applicable codes and regulations before designing or installing electrical systems. The NEC is a complex document that is updated every 3 years, and it is important to stay up to date on the latest requirements. There are many resources available to help electricians and other electrical professionals stay informed about the NEC, including training courses, seminars, and online resources. Continuously learning and staying up to date on the NEC is essential for ensuring that electrical systems are designed and installed safely and in accordance with the latest standards. In conclusion, the NEC permits the sharing of neutral conductors in certain single-phase applications involving lighting and receptacles, subject to specific conditions. These conditions include the use of multi-wire branch circuits, proper breaker configurations, continuous neutral conductors, and load calculations. While the NEC allows for the sharing of neutrals, it is important to carefully evaluate the specific application and consider the potential risks and benefits of each approach. Consulting with a qualified electrical contractor or engineer and following all safety precautions are essential for ensuring that electrical systems are designed and installed safely and in accordance with all applicable codes and regulations. Remembering that a maximum of 10 circuits can share a neutral if the conditions are met per the NEC guidelines. Always prioritize safety and compliance when working with electrical systems.